Hello and welcome to Advanced Algebra. In this lecture, we're going to be going over the interval of increase and decrease, the global max, global mean, local max, local mean of the function. This is a second lecture on these concepts. I started this lecture in class last time. Let's finish it. Let's begin with some examples. Okay, so in the first set of examples, I want you to find the domain and the range, the interval of increase and decrease, the global max, global mean, what and where, if you have any, and the local max, local mean, what and where, if you have any. Okay, let's go over the first graph. Okay, here is the function. So let's start with the domain and range. So the domain, this is about all the x that are in the domain of the function. So you draw a vertical line. If it hits the graph, then that means that this x right here is in the domain of the function, right? So all these x's are in the domain right here, and you see until this blue line. This blue line, we call that an asymptote to the graph, a vertical asymptote, and this vertical asymptote represents the edge of the domain, right? So is x equals -2 in the domain? No, the blue line does not intersect the red graph, okay? So it is not in the domain. So the domain is x above -2, okay? It's represented like this. If you put -2 there, it's everything above -2. When we use interval notation, I know we haven't seen that, but when we use interval notation, this is represented by parentheses, -2, up to infinity, and you always put the parentheses around infinity. The parentheses around -2 means that you have an open circle there, okay? Again, this is interval notation. I know you have not seen that yet, but let's start talking about intervals, okay? All right, how about the range now? So for the range, you have to draw a horizontal line, right? So you see, and for the range, you're looking at the y. This y is in the range because it intersects the graph. So is this one, so is this one, and this one, and this one, and the graph keeps on going there. I didn't draw my arrow, but it keeps on going. Okay, so you can go forever upwards. Now downwards, you cannot go forever, right? These are all in the range, but this is the last one in the range, right? Because if you draw a horizontal line below this one right here, then this y is not in the range, this y is not in the range, right? So it stops at -1.8. So for the range, we will say all the y's above -1.8. Can it be equal to -1.8? Yes, -1.8 is the value taken by this input right here, okay? So I meant this output, of course. So it is above or equal to -1.8, okay? So again, if you were to use an interval right here, if you were to draw that on the line, you would do -1.8, and here it's a closed circle because it's taken, and it's everything above -1.8, right? If you were to draw that with an interval, you would put a bracket. The bracket represents the closed circle, so -1.8 and forever. That's called infinity, and there's always a parenthesis around infinity. Okay, so this is for the domain and the range. Now let's talk about the interval of increase, decrease, global max, global mean, local max, local mean. All right, so where is my function decreasing? So look, the graph goes down from here to here. Now from here means it goes all the way, right? I mean, for every x that is coming from -2, the graph is going to go down. Stops right here, right? Let's specify this interval of decrease. So don't forget, for the interval of decrease, you need to describe the x's, right? So if x goes from -2 to -0.75 right here, so all the x's right there, the y's are going to go down, okay? The function is going to be decreasing. So my first interval of decrease, so decrease, I have x above -2, that's my boundary of the domain, and I have to stop at 0.75, right? For every x in here, y goes down. There's another interval of decrease right here, right? The function goes down right here, right? So where is that? This is from x between, is that 0.25? Yeah, 0.25 to 1.25. For all the x's right there, right? For when x goes from here to here, the y's are gonna move downward, right? So it's from 0.25 to 1.25, or x above 0.25 and smaller than 1.25. Let me show you how we write that with intervals, okay? So this is a very easy interval to write, this one right here. You start at -2, that's your lower bound, and you stop, so you put a comma, you stop at -0.75. And because you don't take the values, right, there's no smaller than or equal to, it's strictly smaller than, you put a parenthesis. That's it. That's how we write this, okay? Or is a union, that's an or, and then you do the same thing right here. 0.25 until 1.25, and I put a parenthesis because I don't have this right here, okay? That's why I put a parenthesis. That's it. These are my interval of decrease. Well, what are the interval of increase? Well, everything else, which means the function is increasing between -0.75 and 0.25, right? So it's right in between these two boundaries there, right in between this and this right here. And then the function is increasing after 1.25 forever. It keeps on going forever right here. You have a horizontal asymptote. It keeps on going up. Okay, the red graph keeps on getting closer and closer to the x-axis, but it never touches it, okay? So the interval of increase will be, so increase, I said between -0.75 and 0.25, so x between -0.75 and 0.25, or x above 1.25, okay? And if you use interval notation, that would be, so here's the left bound, and here's the right bound, and you put a parenthesis, or that's a union, x above 1.25. So this is the left bound right here at 1.25, and then you never stop. So you go up to infinity. That's how we will write it. All right. Global max, global mean, local max, local mean. So I propose we do a table for that. It's going to be easier to specify. Okay, so global max, global mean, local max, local mean. And we have two sets of questions to answer, right? Is what and where. So here's going to be my what, and here's going to be my where. If you don't remember, check out the previous set of notes, okay? All right, global max, global mean. What? Well, global max, you see, let me erase everything here. Because a function grows forever, right? It goes up, up, up forever right here. There is no global max. There is no point that is higher than any other point. Do I have a global mean? Yes, right here. This is the lowest point possible in the function, okay? So the what is -1.8 and the where is 1.25. So let's fill out the table. Global max, nothing, right here. Global mean, what? We said -1.8, and where 1.25, right? The what is the y and the where is the x. Here we go, what is y, where is x. Okay, local max, by the way, because this is a global max, I'm also going to put it in my value for local mean. This is the global mean I meant. I may have others, right? So here, let's do this. Maybe there will be others here, but at least this one is there for sure. A global is always a local, not vice versa. Okay, do I have another local mean? Yes, right here. Right, that's a local mean right there, right? You see how the graph goes? Locally, this is a minimum value for the graph. The what is 0.5, the where is -0.75. So the what is 0.5, and the where is -0.75. Okay, let's fetch our, I think there's only one local max, and it's this one right here. Okay, what 5, where 0.25. Okay, so what is 5, where is 0.25. That's it. Let's move on to the second example. Okay, here is the second example. So let's start with the domain and the range of the function. Okay, so what's the domain of the function? So you see this arrow right here? It's telling you go always towards the left and always towards the right. So I know it's going to start at negative infinity and it's going to end at positive infinity. All right. Now, is everything in the domain? Yes, 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 yes. Except this value right here, right? What's going on right here? You have a vertical asymptotes right here. So -1 is not in the domain. So how do we write that? We say x smaller than -1, right? Or -1 smaller than x. Okay, that means x above -1. Here, let me erase that right here. Let me show you graphically what I mean. It's very simple, right? It means everything but -1. So you have everything here and everything here, or rather I should say or, and this is -1 right here, right? So how do we write that with an interval notation? So how do you specify x smaller than -1? Well, you stop at -1, right? Because you don't have an equality here, right? You don't have an equality. You're going to put a parenthesis around -1. And then where do you finish? Well, you don't finish. You never finish. So this is what we call negative infinity, right? And you always put a parenthesis around infinity. Or, that's a union, what? X above -1. So this is -1 and above. It goes on forever. That's how we write that with the interval. How about the range? Okay, so for the range, we draw horizontal line. Now, not vertical line, but horizontal. Let me erase that. Here we go. Okay, what's in the range? Well, all of these values and everything above, right? Because it goes on forever. Yes, 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 and then nothing below the x-axis. The x-axis is 0, right? Y equals 0. So nothing below the x-axis. So it's y above 0. Is it equal to 0? No, because it's an asymptote right here. It doesn't show, right? The red seems to be right on top of the black, but you know it's impossible that it would become constantly equal to 0. It's getting closer and closer to 0, but it never is equal to 0. So it is 0 and everything above 0 if we use interval notation. So now, interval of increase and decrease. Well, right here, I see that my function is increasing, right? And right here, it is decreasing. So it's very simple. So increase is x below -1, right? If you take any x's below -1 until -1, the y's are going to be increasing. Don't forget, you move from left to right, right? So if you go this x, this x, this x, this x, this x, right here, you see the y's, they're getting larger and larger and larger, right? They're getting very large right here. So increase, x smaller than -1. And of course, decrease is the other side. It's x above -1. Local max, local mean, global max, global mean, it's all an empty set here. The function never does this, right? You don't have a crest, nor do you have a trough, neither a crest nor a trough. So nothing in terms of max and mean. All right, next example. All right, so this graph seems to be a little bit more regular. Let's go with the domain and the range. Now, what's the domain here? Well, you see this arrow, it means it always goes down and it always goes to the left. This arrow right here means it always goes to the right and it always goes up, okay? So the domain is all real number. If you were to use interval notation, you would say from negative infinity to positive infinity in parentheses, right? What about the range? Well, same thing, right? I mean, it's everything right here. Every horizontal line will hit the graph for sure, right? So the range is also all real number. Okay, interval of increase and decrease. Let's get our increases first. Okay, where is the function increasing? So it's increasing on this one right here, on this one right here, and right here, right? So let's fetch the x's. it's increasing for x smaller than -4 right here, right? If x is smaller than -4, the graph is going to be increasing. The y value are going up, right? If x is in between -2.7 and -0.03, you see the y's are also going up. They're increasing. The y's are increasing. So let's start writing this. So x smaller than 4, -4, or second one, x between what? Between -2.7 and -0.3. And there is a last one right here, right? So this one is x above 1.6 or x above 1.6. Let's use interval notation right here. We have three intervals. We have, so the right bound is -4 and it goes down forever. That's negative infinity. Or that's a union. -2.7, -0.3 right here. Or another union above 1.6 and it goes on forever. Okay, these are my interval of increase. And of course, if I write with the intervals like that, it's so easy to spot the interval of decrease. How? Because it's everything that I have not described, which means, right, so everything is taken up, there's a hole right here, and there's a hole right here, right? So the interval of decrease would be between -4 and -2.7, or between -0.3 and 1.6. It's like wherever the function is not increasing, then it is decreasing, right? And you can check on the graph that it makes sense. You have two places where the function is decreasing, right there. Okay, let's erase all of these. And now let's get for the local and global max and mean. Again, I'm gonna do that in a table. Okay, let's put that in a table. So global max, global mean, local max, local mean. Two questions. What and where? What is y? Where is x? Okay, here we go. Okay, well, global max, global mean, local max, local mean. Hey guys, if the range is all real number, the function goes up forever and down forever. So you're not going to have any global, right? That's not possible. So nothing, 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 and nothing right here. Local, all right. Local, let's start with the local max. I see two crests. I see this one and this one, right? That's it. So local max, the what is going to be 0 and 18.4, right? So 0 and 18.4. How about the where? Well, the where is -4 and -0.3. The where is -4 and -0.3. What about the local mean? I see two troughs, one here and one there. That's a what, and that's a where. Okay, so what is -7.9 and -7.7? Where is -2.7 and 1.6? That's it. All right, let's continue with another example. So in this example, I'm asking you to use your calculator to find the interval of increase and decrease of the function. So let's take the calculator. I'm going to show you how to do that. I did show you that in class, but it was very quick. So let's review that. And it's good that it's going to be in the video. Okay, so you're going to have it and you can go back to it. Actually, let me pick the function. -0.2 x cubed. So -0.2, 1, 1, -5. -0.2, 1, 1, -5. So -0.2, 1, 1, -5. Here we go. That's my function. So let me do a zoom standard. That's a window -10, 10, -10, 10. So zoom standard is zoom 6 right here. And that's a typical window, okay? The x mean is -10 and the x max is 10 and y mean -10, y max is 10. Okay, very typical function. It's a cubic function right here. I do see a local mean right here and a local max right here. So decreasing for all the x's smaller than this value right here, whatever that value is. And also decreasing for all the x's above right here. You see the function goes down right here. So basically, to describe the interval of increase and decrease, you just need these two values there. So let's fetch them. So to do that, you need to do calculation. So it's second trace, calculate, right? Second trace, calculate. And let's get the, first let's go with the minimum value, minimum. So I'm right next to it. So you go on the left side and you push enter. And then you go on the right side of that value and you push enter. And the function is going to get the value right there in the minimum, okay? But you have to make sure you're on the left and the right side. Guess, don't guess, you just push enter. That's it. So the minimum value is negative 5.22, and it is at negative 0.44. This is a what? And this is a where, okay? So actually, you know what I'm going to do? I'm going to quickly sketch it like here. It goes, the graph goes like this, right? And I don't know where is the y? Oh, it's almost on the thing right here, right there. And so let's try the value. So we said this is negative 0.44, and the y value is negative 5.23, right? Negative 5.23. So negative 5.23. And let's get this point right here. So how do we do that? Well, this time I'm going to do a max, right? So second trace, right? And we want, oops, what happened there? Second trace. And this time we want a max. So it's number 4. Max. So I got to go on the left side, right? It asked me for the left bound. So I'm going on the left side of it. I'm on the left right here. Enter. Let's go on the right. Let's pass it. Make sure you pass it. Right? Guess no. And the value is so 3.77, 2.27. So it is 3.77 and 2.27 right here. Okay. So for the interval of decrease, is going to be, so decrease right here is going to be x smaller than negative 0.44, right? Everything smaller than negative 0.44, or x above 3.77. And for the increase, well, it's the other one, of course, right? It's everything in between, so x between, so negative 0.44 and negative 0.44 and 3.77. Okay? All right. Last type of examples. So let's go over the last kind of question I'm going to ask you. Determine the domain, range, interval of increase and decrease, and local mean, local max of the function. So I'm only going to do one, okay? I only have time for one. I'll do number 5. Number 6 is exactly the same, okay? And you have a couple of examples to do like that in class. So number 5, what's going on? Hey guys, you know the graph here. It's a parabola, and we also know it's concave down. Now, I don't know where it's going to be, right? Maybe it's going to be above, or above. It's going to cut the x-axis. I'm not sure. But I know the function will have a global max. It's going to have a global max, and it's also a local max, right? We know global is also local, all right? But there's surely not a global mean or a local mean. How do you find it? You know how to find it. We need to complete the square. We need the vertex. Let's find the vertex of the parabola. So the first thing I'm going to do is divide by negative 2. So you have x squared. 12 divided by negative 2, negative 6x. And negative 5 divided by negative 2 plus 5 half. Don't worry about the fraction. I believe it's going to go before the end. Next step. So next step, I'm going to complete my square, right? So it's x minus 3 squared minus 9. That's how I complete my square. Plus 5 half. And so what is negative 9 plus 5 half? Common denominator, you multiply by 2 right here. And so it is x minus 3 squared minus 18, and minus 18 plus 5 minus 13 half right there. And then finally, you need to multiply both sides of this equation by negative 2. Please, some of you multiply this by negative 2. I said in class, this number right here. I said in class, you don't touch what's inside the square. Just put it in front right here. So we have f of x equals, right, that will cancel. F of x equals negative 2 times x minus 3 squared plus, right, 2 negative make a positive, 13. Here we go. So I know where my vertex is. It's at negative 3 and I'm sorry, the vertex is 3 and 13, and the function is concave down. So actually my graph is not exactly like that, right? It would be more like 3 and 13, so I don't know, something like that. 3 and 13, and the graph is concave down. So increase, where is the function increasing? Well, it's increasing right here for x smaller than 3, right? X smaller than 3. And it is decreasing, decrease right here, for x above 3. For x above 3. What is your global max? So global max, you got the what and you got the where. So that's easy, right? The what is 13. That's the y value right here, 13. And the where is the x value, 3. That's it.